So first, I want to go through a few logistics. I hope the 5 companies who are going today aren't nervous and are excited about the opportunity to present, because we're excited to hear your technologies and to see the finished product. I want to kind of go through some logistics. So we are going to break for lunch at 11:45, which will end the live streaming portion of this for that part of the day until we go to Facebook Live later. At 1 o'clock p.m., the impact tables start. So if you can remember where those were located, you can just meet us in the room by 1 o'clock. If you don't remember where they're located, it's fine. You can just meet us in here about maybe 10 minutes beforehand or 5 minutes beforehand. We'll walk you down there. And that's 12:55. Canon is graciously hosting us or providing lunch. Thank you again. And at the most important thing, the judging starts at 3:45 for our chief technologist to review all of the proposals and presentations and the scores. And they will make a selection, and the winners will be announced at 4:45 today. They will be announced on Facebook Live at NASA 360. We will also be doing a Facebook Live and press availability at 5:30 today to introduce those top 3. So between 4:45 and 5:30, we will actually give away awards. So just kind of wanted to put it in your brain, give you an idea of where you need to be and at what time. I want to share a story because, well, that's what I like to do. When I was growing up, all vending machines took quarters until about my teenage years. And all of a sudden, they started taking dollars, which was pretty exciting because you didn't always carry quarters with you. When I sort of had some complications because there are times that as a teenager, my dollar looked like this, kind of wrinkled. Maybe it was found in the bottom of my purse. And so I would try to rub the wrinkles out to try and get the machine to take it. And sometimes the machine would still reject my dollar. If I was, lucky enough and there might be somebody walking by, I would say, could you exchange this dollar for another dollar? But both dollars were of the same value, right? It didn't change value just because this particular machine didn't take my dollar. It's just that this particular dollar didn't meet a set of requirements, right, that this particular machine was looking for. And you're wondering, why is she telling me this story about a dollar? Today, we're going to select 3 top winners. And 7 of you won't be selected to be in that top 3. But it doesn't mean that your technologies aren't amazing. It doesn't mean that those 7 companies aren't out there going to change the world. It just means we have a set of requirements and probably limitations of bandwidth to take more than 3 companies. And so, much to the chief technologist's dismay, I only allow 3 companies to make it in that top 3. And so I want you to just keep that in mind when those 3 companies are selected. If you are part of them, great, congratulations. And if you're not, don't give up. Don't throw in the towel. Don't think that your company is not of equal value to one of those top 3. Because you're going to face other challenges that are going to have to carry you through moving that company forward, that I would hate for you to allow that one to discourage you. So I just felt it was important to share that before I introduce our next speaker. And I have the clicker, right? I want to leave you with my favorite quote. Far better is it to dare mighty things, to win glorious triumphs, even though checkered by failure, than to rank with those poor spirits who neither enjoy much nor suffer much, because they live in the gray twilight that knows neither victory nor defeat. And it's written on a chalkboard in my kitchen, because I know that every day I deal with things that are challenging, but I love what I do, and I'm the one that wants to take the risk, despite the fact that the odds are stacked against me. And that's entrepreneurs. Your odds are stacked against you. That's anybody that's working in technology and trying to develop it and get it out to the market, to disrupt a market, or to change the world. You're going to face those challenges, but how fortunate you are that you actually are one of those people that are willing to take the risk, because there's few of us in this world. But I'm glad to be a part of this, and I get to join forces with you guys who are changing the world. I get to be a little bit a part of it by watching your technology move forward. So thank you all for being here, for participating, and for developing technologies that are trying to make our lives better. If you could help me welcome Jim Reuter. He is my boss, and which is sometimes challenging because I think outside the box. I like to try new things. And when I said we have agency support, I started this program in OCT, and STMD decided to actually take it into their mission Directorate programs because they liked it, they believed in it. And so I wanted Jim to kind of talk to you a little bit about what that means to STMD and how that is integrated in the agency overall. So please help me welcome him up here.
Okay. Good morning. Can you hear me? Well, thanks, Kira. You know, I was listening to her story there on the vending machines. I was thinking, well, I grew up on a farm in the middle of nowhere. I don't remember there being vending machines when I actually grew up, except for those ones with the bottles, those old style ones. So, and then, you know, then she's the one that reads paper books, and uses chalk. So I don't know. I'm electronic. Anyways. The first thing I want to do is really thank everyone here and express my great appreciation and excitement for being able to be here the last couple of days and getting to participate in the last round when we looked through, I think it was 25 proposals and narrowed it down to the 10 that came here. And I want to thank, first of all, Canon especially for the outstanding host that you've done. It's just been incredible. I hope that we can continue this. And, you know, I went through that tour a couple days ago, and it really struck me how, you know, if you're in the imaging business and you look at it from a life cycle of the input to the output, then there's no limit of the number of applications for that, both for us in space and on the ground. I also want to thank all the people that are participating, the chief technologists, the entrepreneurs, the investors. You know, it's ingrained in the soul of a NASA person, I think, if you've been there a while, that the best way to get a product is to have an open communication and a diversity of opinion and perspectives and backgrounds. And as long as you have a measure of urgency with that, so that you lead towards a solution as opposed to continued debate. But that is just ingrained in everything we do, and it really comes out of both the Challenger and Columbia accidents. I also, of course, want to thank Kira and her amazing team for hosting this. It takes way more hours to get ready for this than to actually conduct it. And there's all kinds of things that go on in the background and behind the scenes to make this appear seamless and easy, and of course, it's anything but. So as I kind of alluded to, this is a big day. Of course, this afternoon, there's 10 winners already. And then we'll down select to 3 this afternoon. I'm really looking forward to seeing that. But it's a big day from another reason too, a really important day in NASA's history. It was 15 years ago today, February 1st, 2003, that Columbia tragedy happened. On that day, we lost 7 of our astronauts and a big part of our hearts. Rick Husband, thank you. Willie McCool, Michael Anderson, Kalpana Chawla, Casey is what she was known by. I can't pronounce her name otherwise. David Brown, Laurel Clark, and Ilan Ramon. He was set to be the first Israeli astronaut in space. Casey, I believe, was the first Indian astronaut in space, but it was, I think, her 3rd flight, if I remember right. anyways, I just invite that we have pause for just a moment of reflection. If you're like me, you probably remember exactly where you were at that time. For me, interestingly enough, I was in New York City, near Times Square. There's been 2 times in my career, mostly I've worked human spaceflight. 2 times in my career I've actually worked technology, the last 2.5 years here in Space Tech, and about a year, and for a year back in 2002 to 2003. So I happened to be up here in DC on a rotation, and I had my family with me. I have twin daughters, and it was their 15th birthday. So and I have a son that was 7. And we took the train to New York. It was, I think, as I remember, that Saturday morning was about single digits in temperatures, at least in New York, and man, it was cold. But what we did was we went outside, to the Today Show, where they have the people there, and they come out with a host and interview people and stuff, and there weren't that many people there that in 5-degree weather. So our kids were able to get right up front. They had the sign that says they're 15, and they got interviewed there. They went around to other people and they interviewed them again at the end. And we went back to the hotel in Times Square, and my son and I were in the gym, or the exercise facility, when on TV it came in the announcement. And as soon as they said it was a minute late, I knew. Anyways, yeah, I was living in most of our family was in Minnesota. We had a lot of friends. I'd lived a long time in Alabama, so that was Central Time Zone. And my kids were the last thing on, and because of delays in things, my kids were the last thing on before they cut away in Central Time Zone. So anyways, that's where I was, and I'd like to hear others too. We talk. Okay, so now I'll proceed along. What I'd like to do is talk a little bit about space technology, our thought process for how and why we invest in things, and then how iTech fits in among our other programs and what we try to do with those. So what we've tried to do over the last couple of years, especially this last year, is try to think strategically, can't say that twice, about where we should invest and how. Space tech for NASA is to do cross-cutting transformative technologies. And we're trying to do that in a lot of ways. And so we came up with what we call strategic thrusts, 6 of them, that you can see on the right side of the screen. But in order to, and we've iterated this, we've talked with industry, we've talked with others to get input to it, to refine to this list, and it's still actually being refined. The intent was to try to do something that would stand the test of time as we get different guidance, different space policies, that it can still work. You just have different emphasis within the categories. Anyways, but before we tried to do that, we wanted to talk about the trends in the industry and think about those, because that can really influence both the strategy and the implementation. How do you do acquisitions and stuff? And so we came up with, after a series of discussions, of 4 mega drivers shown on the left side of the screen. And I'll just talk about them briefly. The first one is increasing access. It's, there's right now you see a trend towards lower cost of access to space, increased availability, and diverse platforms. CubeSats, small spacecraft, things that, things are downsizing because of the capabilities that we were able to fit. And CubeSats are, of course, the ultimate extension of that, or I think it's maybe not. Actually, probably not, because there are some gram level things. But anyways, the CubeSat is, toaster size, or a little smaller, a little larger and stuff. And it was started in 1999 by Cal Poly University as a teaching tool. And it's grown to $1 billion industry over time. So it's things like that, and the availability of secondary payloads, hosted payloads on almost every flight as it's starting it just provides a lot of opportunity, and it's something we want to think about as we put our thrusts together. The second one is the accelerating pace of discovery. All you have to do is look at the number of Earth-like planets that are starting to be found, and planets around solar systems, and see the explosion that's been happening on that. And with that, the intensity of exploration and the desirability to do that by private investment. And after all, an awful lot of the over the world history, you look at where has It hasn't always been governments, you know, and often has been the private entrepreneur that has actually led the way. The democratization of space. There's really what we're seeing is much broader participation, much higher private investment, an emphasis on public-private partnerships, and much greater international participation. In 2017, the non-government investments for space companies, so not even counting the stuff that's going on here, was $3.9 billion, which is a substantial increase over the year before and the year before that. 2015 is when it really started taking off, and the curve is purely exponential right now after being flat for years. On the international front, I thought it was a few more than this, 71 government space agencies right now, with 13 of them having a launch capability. And I think those numbers are a little higher now, but that was 2017 data that I could find. And a lot of them come together on the International Space Station as a platform and for that. And the final mega driver that we thought about was the growing utilization of space. The space market diversity right now, servicing of satellites in a nascent form of industry, manufacturing in space, and for use in space and for use on the Earth, assembly in mining. And so those four together is what we thought about to say, okay, what should our strategic thrusts be? And so I'll talk of those briefly. And the first thing I'd say is those thrusts are more than what space tech can do, but there are things that we think we can play a central role if we're strategic about this. And it doesn't mean that they're equal in terms of our investment strategy. The first one is to accelerate the industrialization of space. We've kind of been talking about that, but there's servicing, assembly, manufacturing, resource utilization. There's plenty of examples we think of. It can be really a next major push in space. One example might be we want to find life on other planets. One way to do that ends up being to search at a level that you really kind of need about a 20-meter telescope. A 20-meter telescope in today's fairing size just is not really practical. But if you could assemble that on orbit, we can change our whole exploration. The second one is to enable safe and efficient transportation into and through space, access to space, lower cost, reliable stages. We're looking for our way of helping that. And in space especially, for more efficient and or faster. Those two can be mutually exclusive, but they can also really change where we do business. And that faster can be ultimately a goal towards interstellar travel, even if it's at the gram size. We actually had a study that in one of our innovation, we call it NIAC, that led to an investment of $100 million by Starshot for trying to do just that with directed laser energy. The third thrust is to increase the access to planetary surfaces, safely and precisely deliver payloads and humans access to the highest value science sites and do sample return. So it turns out that if you want to get close to the science sites, you tend to get to the place where there's a lot of hazards for landing. And so where there's good places to land often, but they tend to be not as interesting. So things like precision landing, hazard avoidance in an autonomous manner is something that's really critical for us to enable exploration. We have a terrain relative navigation system that's going on Mars 2020 in an open loop mode as part towards that. Then ST4, enable the next generations of science discoveries. For us, it's new platforms, better capabilities, greatly enhanced data quality and quantity. The science instruments themselves is what Science Mission Directorate focuses on, and we work hand in hand. They have a great system, as we all know, on the decadals that guides the investment strategies and guides us in terms of our strategy as a result. And things like where those next generations can be is things like the icy moons of our solar system. Europa is one that's often mentioned. We believe below 5 miles or so of ice, there's liquid water. And with that, and it's a volcanic activity in that, so at those places of volcanic activity, there's carbon. And there's warmth. And so we have the essential ingredients of life there, if we can figure out a way to get all the way to Europa, land safely, and drill through 5 miles of ice. And then observe. and the radiation. Okay, but exciting. And a pet project of the House Appropriator for Science. ST5, our fifth one, is to enable humans to live and explore in space and on planetary surfaces. Space habitation, radiation protection, reliable beyond Earth orbit, and safe, and improving crew effectiveness. You know, I worked 7 years on ISS from the day it officially started. Well, actually, I was brought in on April Fool's Day in 1993, and left about 7 years later when we went to permanently occupied. Said, okay, I'll do something else. And I worked life support, environmental control during that time, and led that activity. And so what I know is we went through a lot of iterations on how we could make an international space station with multiple international partners, especially with the Russians, and do that in a safe way where we could keep them live and safe. And we had the advantage of being close to Earth and having steady logistic supplies to make that happen. And to make that next step to cislunar space and then on to Mars requires, again, order of magnitude improvements in our reliability and safety. And especially on a Mars visit, unless we really change our thinking on the propulsion system, we're going to be very limited on our return capability in the case of a contingency. So it's an essential thing for us to be able to go forward. And crew effectiveness, you look at crew aids. How can we use robotics and other sensory devices to just help the crew? ST6 then is grow and utilize the U.S. industrial and academic base. For us, that means transferring our technologies that we develop, expanding on our use of public-private partnerships, driving U.S. innovation, and expanding opportunities to achieve NASA's and America's dream. And that's where iTech fits in. We need to recognize that you know, I've been 30-some years at NASA, like I said, most of it in human spaceflight, and so most of that time, we dealt with contracts, large contractors. There was intellectual property rights concerns, but typically at a smaller level, not within the whole mission, not within the whole capability. And at that level, we would negotiate those sort of things, and they would invest their own private industry funds for those specific items, but not for as a whole. We didn't buy services. We didn't use fixed price contracts, by and large. We're just such a different environment right now, and we need to recognize that. And so iTech then is its own creativity for us. You know, so when you're used to doing things a certain way, you got to bring in different insights and perspectives to be able to enable you to change. And so Kira is, as she said, she's different than NASA in a very good way, and we really appreciate all the work she does and the insights that has been provided and getting us here today. So I probably am past my time, but just real briefly, what I'll say is then, so those are our thrusts. That's our thought process for what we should invest in. Then when you invest, we try to, you know, it was introduced yesterday, at least in the hydrogen storage presentation about the technology readiness level you talked about it that way, and we were at TRL3. So that's common language for us. In fact, and it's a scale of 1 to 9, 1 being basic research, 2 maybe being more applied research, 3 being demonstrate in the lab, 4 is when you start getting a prototype. 6, by the time you get to 6, you have something that's a development, a true prototype that's you're starting to see environments. And then 7, 8, and 9, you're starting to demonstrate those in the actual environments, including for us, space. And so when we manage our programs, it's really different mindset to manage something in early stage and something in the flight. And so we're organized around that for that reason. And I won't go through all these other than to say at early stage, our goal is that's really push technology. Our goal is to have about 10% of our investments as a space tech in that area. We're probably about 8 right now. And about 2/3 of what we invest go to the universities. We have multiple university programs from research fellowships to early career to universities working with industry and to some research institutes with multi-university activities. And then about 1/3 of it goes to our NASA workforce or just, as I talked about the NIAC on the one example, that's open call to anybody. It can be a person in a garage, it can be a NASA person, it can be in a university, it can be an industry. If you have and the constraint is you don't violate the laws of physics. And so if it's we'll pay $125K to allow people to go investigate that. And if they have something good, they can win a $500K for 2 years of studies. And so that's our early stage. Mid stage, we tend to, and later stage is where we really try to focus on public-private partnerships. We recognize that today's environment, intellectual property rights is a very key concern in terms of investments from others. Now, we also have a constraint ourselves. If we're investing our government funds, we're basically required to retain some intellectual property rights. An exception being SBIR, where it's kind of built in, but there's still some qualifications on that and sunset clauses and stuff. So by and large, we do that, but we have a variety of mechanisms with public-private partnerships that we can work. One of which that's really successful is we have Space Act Agreement Authority, and in a non-reimbursable Space Act Agreement, we come to a mutual agreement with a company and that has a product they're trying to develop. It's of interest to us, so we're willing to invest our technical expertise and our test facilities to them, no exchange of funds, and under that they retain intellectual property rights. And encompassing all that, we have a number of different commercial partnerships that we're trying to look at how we can do that. This SBR program, as I mentioned, is really a great one. We have a phase 1 and a phase 2 call. Phase 1 is out right now, and we typically get about 1,600 proposals. About a quarter of those is what we award for phase 1s, which is $125K for 6 months. And then we turn around as quickly as anybody. We're the best in the federal government, at least we believe so. We turn around and they can get phase 2 for up to $750K for up to 2 years. And then beyond that, the goal is to get that at a ready state to be able to be invested either ourselves or in commercial. So that's through a phase 3. If you want to use our contract mechanism, it's an easy way for us to turn it on very quickly, or if we want to. And we also do a phase 2 extended, basically, which says it can be a bridging. And under those conditions, though, it's got to be matching funds. There has to be some skin in the game. So it's one that we think has a lot of potential. It's one we've been working on really hard over the last couple of years since I've been here to try to improve. And really, it's one we want to. In fact, one of the stated goals I'll probably get the words wrong, but stated goals of the SBR program for government-wide is to develop ways to to increase the commercialization of products that have been developed using federal funds, something like that. And then we have a tech transfer program. Flight Opportunities is a program where we sponsor payloads for suborbital platforms. We have agreement with some of the nascent providers, and while we don't pay for the payloads, we provide them a small amount of money for integration and provide the launch. So, but in that way, we're trying to increase the market, basically, and help both the supplier, the service provider, and the payload. And they actually work directly with each other to actually get manifested and flown. Centennial challenges, we do a lot of challenges programs. Is it time? Okay. And then we also do regional economic development, where we look to use our expertise in disadvantaged areas. So with that, I just want to end by saying I'm really excited to be here. I've really enjoyed the time I've been able to spend with this, and look forward to the day ahead. And we're going to announce 3 winners today, but we have 10. Thank you.